Good afternoon for everyone. My name is Samar from Reis. Today I will talk about graphene, and I will answer some questions like, for example, what is the graphene, why graphene is so important today, why the last between 3 and 5 years we can find more than 3,000 publications and articles about graphene. But today my main question is, why is graphene the material of the future? So first of all, I will start explaining what is the graphene. So graphene is a thin layer of pure carbon. Graphene is composed of atoms of carbon, and the format of graphene remember us like beef. The graphene has a format of has a hexagonal format, as you can see here. Each atom is connected to another in such a way that remember us a beef. Another important characteristic is that the graphene has a thickness of 1 atom. So even not a helium atom can pierce the graphite. So you can think like if you put 3 millions of graphene the same line, you will see 1 millimeter of graphene. So graphene is very, very small. So today the graphene is considered the material of thousands of utilities, thousands of uses because of some characteristics, special characteristics that are strength, lightness, transparency, flexibility, as well as being a great conductor of electricity and a high thermal conductivity too. So I'm sure that in the future the graphene will be considered equal to or more than revolutionary of plastic or silicon, because some engineers and chemistry and physicists are working on the graphene, and they are discovering that the graphene can substitute the silicon in several kinds of dispositives like telephones, cell phones, computers, and other kinds of devices. So I showed you some characteristics like strength, and the graphene is 200 times stronger than steel. So this is one of the most important characteristics of graphene. But you can think that if graphene is 200 times stronger than steel, it's also unflexible, it's also rigid. But you cannot think that way. The graphene is also flexible. It's 200 times stronger than steel, but it's also flexible. And that makes the graphene so special. As I said, it has a high thermal conductivity and a high electrical conductivity. So I have here some chemical characteristics of graphene, like the graphene electrons can move freely in relation to other chemical materials. Consume less electricity than silicon, and this is a very important point because, for example, in cell phones we have silicon, and our computers have silicon, and today we have a lot of concerns about how we use the energy and how the energy is consumed. So if the graphene can really substitute the silicon, in the future, we can consume less energy using the graphene. So a lot of companies are working on that. So heats up much less than any other materials, supports ionizing radiation, and it's almost completely transparent. So as I said in the beginning, not even helium atoms can pierce the material of graphene because it's very small. So these are some chemical characteristics. I cannot tell you about graphene without tell who are the guys that discovered all of it, who are the genius. And these two guys are the genius that must be mentioned today. They received the Nobel Prize in Physics 2010 because of his revolutionary discoveries about the graphene. But they published the research on 2004, but they received the Nobel Prize 6 years after that. Maybe the organization was proving his theory, I'm not sure. But another point is that the graphene, whose existence was known since the decade of 30s. So after almost 100 years, now they are focused on graphene, and they discovered all of it. Maybe because of some economic reasons, now they need to substitute the silicon for another material. I'm not sure, but it's another topic for another time. So these are the two guys, Andrew Jean and Konstantin Novoslov. So here I have a picture, two picture. That's how the graphene can be arranged. They can be arranged like nanotubes, and the nanotubes directed us to nanotechnology. And the graphene, if the graphene can really replace the silicon, in the future we will have the second technological revolution. So important characteristics of graphene for some device is that the graphene can process data 10 times faster. So imagine your cell phones, your computer 10 times faster. And because of the flexibility, in the future we will have some device like this, bracelets that are flexible, that can substitute our computers, our cell phones, can be a calendar, agenda, TV, or whatever you want. So a simple graphene plate can be a clock, as I said, and as you can see in these pictures. And the flexibility of graphene allows use it as a bracelet or a screen. So the graphene will improve areas which the human being develops, technologically speaking. But if you think the technology is in our life, where we go. If I'm home, if I'm at the university, if I'm in a bar, we have televisions, we have cell phones, we have all that kind of stuff. So the technology is completely in our lives. So if the graphene can substitute the silicon, will change our lives in such a way that we cannot imagine. For example, we can have in the future chip of graphene that can have a high capacity, and that will be more faster than the actual graphene chips are. So let's pass. So maybe I arrive at a point that maybe you are asking for yourself, why we don't have these devices now? If we know the capacity of graphene, if we know that graphene has a big potential, why we don't have this device? Because we don't have the technology, the appropriate technology to lead with the graphene. We know the graphene is a good material, but we don't know how to use it in the correct way yet. But we have a lot of physicists, engineers, and chemistry working and researching about that to make it possible. And another point that's very difficult, because when we are talking about graphene, we are talking about nanotechnology, and it's a very small scale. The scale of nanotechnology is a nanometer, and a nanometer is a millionth part of 1 millimeter. So it's very small and very difficult to lead with this. And for you understand what is technology, I put a definition here, and nanotechnology is a field of applied science for the control and manipulation of materials at the molecular or atomic level. That's why it's so difficult to make these products real for us now. But I'm sure in the future it will be possible. So again, here are some of the benefits that graphene can provide us in the future. Like, I know some kind of this stuff. For example, interactive class. We have interactive class like now, but I mean, the graphene is very cheap. It's cheaper than any other material. It's cheaper than silicon. So if the graphene can substitute the silicon, these materials will be accessible for all of us. I mean, in the future we will have a mirror bath with a screen that you can read news, that you can leave messages. I know that
Iron Man.
Yeah.
Awesome.
Looks like impossible, but I hope that in the future will be possible. And we'll have products that are more resistant. Like I said in the beginning, the graphene is 200 times stronger than steel, so our computers will be more resistant. We are expecting a new world where we will have the concept of technological houses, where our cars are more technological and more efficient, more faster, and all that kind of stuff. As I said, our car will have screens like that can process the data much faster. In the future, we have wives cooking and watching TV at the same table, and I mean, all the world will be more technological. I know that's superficial, but I believe that. And I said, we'll have cars like that. The graphene can substitute a lot of materials. So because of that, and because it's flexible, in the future we'll have the concept of roller computers like that, where you can roll your computer.
Oh yeah, I've seen that somewhere.
Yeah. So I mean, the graphene will revolutionize the automobile materials, aircraft, satellites, ballistic vests, solar cells. So all kinds of stuff that involve technology will change if the research on graphene improves. So I mean, I hope I taught you something, and I hope that you learned something about graphene today. And thank you for listening to the